Hey folks, how's it going? This is Mr. Murray coming to you with another Do Now video for Course 2 Honors. This one is for Thursday, April 30th, 2020, the last day of April. You might even argue we're about more or less a third of the way through the year. For sure, we've made it through 31 plus 29, that's 60 days, plus 31 days, it's 91. So we made it through 121 days. Wow. So it's about 33% of the way through the year. In any case, in this problem, here's what you're doing, folks. You're finding for me the arc length and the sector area, given that we know this about the circle. This is going through the center. And we know that given the arc that we're trying to find in the sector, right, this is the central angle, right? And remember, it's called a central angle because it goes through the center of the circle, right? The center of the circle is its vertex. Whereas an inscribed angle is one where the center is not the vertex of the angle. So what we need to do is we need to find the arc length, and I'm highlighting in blue the arc we're looking to find. And we need to find the sector area, which is this bit that I'm highlighting in purple, okay? Given this measurement and this measurement here. So take a moment, pause the video, find the arc length and sector area, okay? And then when you're ready, unpause, and I'll show you how to solve. All right, Mr. Murray coming to you with a quick hint before I show you the solution. Remember that it's very similar to finding when you're doing degrees. So remember, with degrees, you would take your measurement, whatever the angle is, you would divide by 360, and you multiply by the area to get the sector area, or by the circumference to get the arc length. It's a similar idea with the radians. Think about how you do it. So take another second, pause, or if you need, you skip past the pause, and then when you're ready, unpause, and I'll show you how to finish solving. All right, so basically, like I said, it's the same idea, except now you're not dividing by 360 anymore, because 360 is with degrees and you want radians. So you're dividing by 2 pi, because that it's not out of 360 anymore. When it's in radians, it's out of 2 pi. So we're going to take our angle, 5 pi over 9, and divide it by 2 pi. And that's the same thing as taking whatever that is in degrees and dividing. And for that matter, if you can convert 5 pi over 9 to degrees, so for example, I know that 5 pi over 9 times 180 over pi, that's about 100 degrees. I could put in 100 and divide by 360 and do the problem out like that. That's completely fine. Okay, so in any case, I'm going to do 5 pi over 9 over 2 pi. And you can look at that as also being like 5 pi over 9 times 1 over 2 pi. So that's 5 over 18. Okay, that's my ratio. Now, I'm going to find the total area. So the total area is pi. Now look, this is the diameter. So the other thing you need to remember is you're not squaring 80, you're squaring 40. So that's equal to 1600 pi centimeters squared. And the circumference is equal to 2 times pi times h, or 2 times pi times r, 2 times pi times r, or pi times the diameter. Okay, and since we already have the diameter, we're going to do diameter times pi, centimeters. Okay, last step, we need to take the 5/18 and multiply it by 1600 pi, and that gets us the sector area. So I'm going to do, on my calculator, 5 divided by 18 times 1600, and I get 444.444. So I'm going to hit the math button. I'm going to do option 1, 2 frac, and it will say ants to frac, and then I'll do it again, and I get 4,000 over 9. And this would be one way to do it. Or if I ask you to approximate it, maybe to 2 decimal places, 444 and 44 hundredths centimeters squared. Okay, if you were to do it out, where this comes from is the idea that if you're going to simplify this, you'd have to do maybe divide this by 2, divide this by 2, and then 5 times 8 is 4,000. So, okay, so area is 4,000 pi over 9, or 4,000 over 9 pi, or approximately 444 and 44 hundredths centimeters squared. Arc length. Last but not least, arc length. We're going to take our 5/18ths. We're going to multiply by the total circumference. And we don't need to have the cm there. What we actually want to have, if anything, is that. Also, sorry, as a quick correction, we actually want 4,000 over 9. I just realized 4,000 over 9, okay, pi. So that is more closely, I just realized, approximately 1396.26. What I had done is the 4,000 over 9, and the 4,000 over 9 is the 444.44, but you have to do that times pi, because it's 4,000 over 9 pi. Okay, here we're going to do 5 divided by 18 times 80, and we get 22.222222. If I convert that to a fraction, I get 200 over 9 pi centimeters, which is approximately 69.81. Okay, and I just use the pi button, or you could use 3.142. Okay, so thanks for watching. I really hope you're able to get these questions right. My goal in showing you this is to remind you that solving things with circles with radians. I'm thinking course 1. Solving things with radians and circles is the exact same way as solving them with degrees. With degrees, we took the central angle, we divided by 360, and we took that ratio and we multiplied it by the area to get the sector area. We multiplied it by the whole circumference to get the length. It's the same idea, except now, instead of doing it out of 360, we're doing it out of 2 pi, because 2 pi is the equivalent of 360 when we're working with radians. And remember, whenever you see a pi in there, that's generally a sign that you're working with radians. Okay, so again, hopefully you're able to get this right. I'm really looking forward to some great work today. Continue to move on with circles and inscribed angles. Stay tuned for the coming updates. Have a wonderful day, and I'll see you next time.